Okay, hello Calc students. Here we have a rational function, and we're going to use first and second derivative tests on this function. Now the thing I want you to notice right away is we're going to have some problems here at x equals minus 2, and we're going to have a vertical asymptote there. So that's going to show up in our analysis, you'll see, when we start taking derivatives and look at our derivative tests. So first thing I'm going to do is take the first derivative, and here I use the quotient rule. So the derivative of x minus 1 is simply 1. Then I have an x plus 2 minus x minus 1 times the derivative of x plus 2, which is simply 1. And then I have, this is over x plus 2 quantity squared. Now look, these are not factors. X plus 2 minus x minus 1, these cannot be factors because factors mean multiplication. You're subtracting these two quantities. So the only thing you can do here is simplify. Do not think that these are your factors now. Factors mean they have to be multiplied by each other to be factors. That's definition. Okay, so I multiply by 1 and I simply get an x plus 2. If I multiply this by 1, I get x minus 1, but I'm going to distribute this minus sign. And then you see that the x's cancel out, so we're left with 3 over x plus 2 quantity squared. Now, I don't even have to do a sign chart at this point. The reason is that 3 is always greater than 0, and x plus 2 quantity squared is always greater than 0. So f prime of x is greater than 0 for all x. However, we have to be careful here. It blows up at x equals minus 2. So we will put that in there, as long as x is not equal to minus 2. So when you do your intervals, this thing f is increasing, then it seems like it's always going to be increasing, but you have to pull minus 2 out of the interval. So f is increasing always, except at minus 2. You have to pull that out. Okay. Now let's look at the second derivative. So I'm going to focus on, here's f prime of x. I'm going to focus on this form here. And when I take the second derivative, probably the easiest thing to do is to write the first derivative as 3x plus 2 to the minus 2 power. And when I take the second derivative, I get minus 6 x plus 2 to the minus 3. And then when I take the derivative of the inside, that's simply 1, so that's not going to change anything. So I get f double primed minus 6 over x plus 2 to the third power. Now these are my linear factors. So I will do a sign chart with f double primed. I will extract, watch how I write this. I'm going to write this as 6 over x plus 2 times x plus 2 squared. So I can ignore this x plus 2 quantity squared, because the cube will go, in terms of sign, as x plus 2 will go. So when I do my sign chart, I'm only going to do minus 6 and x plus 2, because x plus 2 quantity squared, look, it's always positive, so I'm just going to ignore it. Whoops, sorry. So there's minus 6. I include the negative, I include the minus 6 because it's going to help me keep the signs straight. So x plus 2 is going to be 0 at negative 2, but that's where the asymptote is. Okay, so really we're seeing what's happening with the asymptote. So negative 6 is always negative. X plus 2 is aligned with positive slope, so it's going up this way, and here's the intercept. So it's negative, positive, so it's increasing to the left of minus 2 and decreasing to the right of minus 2. I'm sorry, that's the not increasing and decreasing. I apologize. That's f prime of x. This is f double primed is positive to the left of minus 2 and negative to the right of minus 2. So that tells me that f is concave up to the left of minus 2 and concave down to the right of minus 2. So I would put in that f is increasing from minus infinity to minus 2, and increasing from -2 to positive infinity. And then f is concave up, according to my analysis here, to the left of -2. So from -infinity to -2. And f is concave down on the other interval. Okay. So just a quick review. Quotient rule, simplify the numerator. Notice I don't have to do a sign chart because this is always positive, always greater than 0. I do have to pull the -2 out because that's where the asymptote is. That's where the asymptote is in the function. So it's increasing from -infinity to -2, union -2 to infinity. Then I use a second derivative test to determine concavity. Or I use the second derivative information to determine concavity. The second derivative test is for testing whether or not we have a max or min. So it looks like we'd have a relative min somewhere to the left of -2 and a relative max to the right of -2. And then we can put the intervals for concavity here. All right, that's it. Well, good luck.